The ocean is a mysterious world that is not easy to reach. However, people have a curiosity for this strange deep world and would like to know what kind of marine creatures live in the deep ocean, especially those little children. Also, we're not satisfied by just looking at pictures to get to know the sea animals. We want to make the learning progress more interesting and more interactive. Using motion capture technology, we developed an interactive marine life education system for children to enhance the experience for them to learn the sea animals.
And we called it Marine World. As Junshu said, Marine World is an interactive multimedia education system based on a motion capture technology. It's used to help children learn about the different types of sea life that live in all the parts of the sea. In this installment, you walk on a virtual water pool that creates ripples wherever you step. In the water, there are sketches of different types of sea life, and if you stand over them, interesting facts about that animal appear on the wall display in front of you. Hopefully, by doing this process in the different levels of the sea, you might learn something new.
For this project, we used 2 programming languages and a motion capture system. We're using a motion capture system called Motive by OptiTrack. This is the heart of our program and also the place we get the data from. Basically, it can track the user's movement in 3D space in the specified motion capture area. Motive can get your X and Z axis location on the floor and your height, which is the Y axis. The location capture results should be different depending on how the system was calibrated. But don't worry, we already did the initial wanding and calibration and saved it as a project file on the corresponding computer. So you just need to launch and run the file.
To getting started, first you need to switch on the Motive hardware. Next, just open the project file Marine World, and the Motive software will be launched, as well as these mocap cameras. You also need to click on this shortcut, which is a test file to change the IP address of your laptop so connected to the projector on the floor, which I will talk about that later. Finally, you need to open this shortcut, which is an executable file to send the mocap data to your laptop. You might ask, how does this mocap system track me? Use this. This is a rigid body with 3 markers. The mocap camera will detect this rigid body and get its location in the mocap area. Wear this on your left or right foot. Now you are ready for the mocap system. Go to your laptop. Connect your laptop to the projector projecting to the floor. Open the file that's also called Marine World. This is a program coding in Max, a programming language by Cycling 74, and we call this file a patch. After you open this patch, you will see this screen. This is the user interface, which looks beautiful and simple to use. First, just press the on-off button to turn on this whole thing. Then, you can see the window below is showing a blue screen, which is a water pool. There are 3 buttons at the bottom, represents 3 different sea levels. Click on one of those, and you can see some sea animals appears in the water pool. Press this button to show the water pool in a separate window. Drag this window to the projector screen. Next, press this button to make it full screen. Here you go. You have a giant water pool now. You can also play a background music if you want.
Now, with the rigid body attached to one of your shoes, you can go into the water pool. And congratulations, you are currently walking on water.
Next comes with a simple patch called put.maxpath. This is a simple patch that you can use mouse to click on this window to make ripples. When the mouse clicks in this window, an output 1 will be returned. It is a 160x120 window with a gray background. For our project, first, we changed the input from the mouse to the scaled mocap data, while we still kept the mouse input for debugging with these switchers. In the patch, we are using the method UDPreceive to receive the data sent from the motive system. Then, we changed the resolution of the pole window from 160x120 to 640x480, which looks more beautiful and less pixelated on the projector. Then, we changed the color of the pole. You can change 3 colors for 3 different sea levels: sunlight zone, twilight zone, and midnight zone, as well as those different types of sea animals in each sea level. Just simply pressing buttons to switch between the sea levels. You can see the water pool on the floor is changing, not only the colors, but also the sea animals in particular sea level.
As part of the mocap calibration process, we set the ground plane, which determines the location value, on the upper left-hand corner of the projecting area. Wherever the ground plane is placed determines where your x and z coordinates are 0, 0. We then use the scaling method to scale from the mocap location data to the projector's resolution, which is 640 by 480.
We used the height value for making this effect. For the height, we designed to make ripple effect happens when user is walking on the floor in the projecting area by slightly increasing their foot's height. Also, if the foot is already on the floor, the ripple effect should not appear. I tested this height and made an if statement that if the height is in the area that is slightly higher than the floor but lower than the height that your foot is rose when you are walking, which is between 90 and 100, an output 1 will be returned, as same as the value when testing the code using the mouse input. In addition, we found a lot of pictures of the sketches of the creatures on the internet, and using Photoshop and Illustrator to make those as a white stroke color with transparent backgrounds, and make 3 640x480 pictures, also with transparent backgrounds, for different sea levels. Finally, I used the method up with a plus operation to add the pole and the fish together.
Now that the sea creatures are under our feet, we'd still like to know what they are. So, first, you'll want to make sure that you have another laptop connected to the projector that displays on the wall. Then, open the processing file Marine World, press the Run button, and your display will go full screen. On the wall, you'll see the same color being projected as on the floor. Now, if you stand on any of the sketches, a better picture will appear on the wall, and you can get to know the sea animal that is just under your foot.
In order to map out the fish, we obtained the x and z coordinates of each of these animals from the max patch. And then placed the maximum and minimum coordinates for each of them in the processing patch. We did this by assigning an if statement to each sea animal. Each if statement contains the sea animal's corresponding max and min coordinate. Also, if you change the sea level by pressing the buttons in the Max UI, the processing patch will follow suit and change the same sea level to match the color and the information for the particular sea animal that was stepped on. The processing patch is receiving the data using the format IFFFF, which represents the integer and 4 floats that represent the rigid body number, the scaled X, Y, and Z values, and the sea levels. In the max patch, we use the pack method to pack these 5 values into one banging message, and use the UDP send object to send this output to the processing patch on that laptop. As you can see, the laptop's IP address is needed for sending and receiving values.
Be sure that the laptops are connected to the same Wi-Fi.
In the max patch, the IP address of the laptop running the processing patch needs to be updated if the IP address happens to be changed by something such as a reboot or a network reconnection.
Also for the motive system that's storing the IP address of the laptop running the max patch.
And tape that rigid body tightly so that it won't fall off. Enjoy this interactive education system, kids, and don't try drinking the water, or the fish will kill you.